Okay, so this chapter is about stress and strain. We are now moving into solid mechanics part in our subject. So this is about stress and strain. This objective is to understand the concept normal. We have normal and shear stress. So we have number one is normal stress. Number two is shear stress. So there are two stresses type that we will learn today, and the other one, the objective is to analyze and design of members subjected on axial load or shear load. So axial load is about your normal stress, and shear load is shear stress. Okay, shear load is shear stress. So you have to learn two basic stress in this chapter. Okay, the figure shows the first one is about your axial load. So this is what we call axial load. And when the axial load pull your part, pull your part, we call it as tension load. Tension, and when it is a push, so we call it compression. So this is pull and this is push. Normally for pull type, for tension, we learn to note it as positive sign, positive value if it is in positive, in tension direction, and for compression, the sign is negative. And the equation of stress is, we call this as sigma. Sigma is equals to force P, okay, P over A. A is, this is force, and this area. Which area? Area that act normal. Okay, so this area is normal area. If you have, let's look at the first figure. If you have force P acting on your body, on your parts, on your components, and the normal area is acting perpendicular. Perpendicular is bertentangan. Perpendicular is 90 degrees. This is your area. So in 2D direction, we have 2D view, not 2D direction. We have P acting on the body, and this is our area. So if we look at from the top, our area is the area of the beam. Okay. If you have a square or rectangle beam, it is according to the A, B times H, okay, or B times D, right? So this is the area, and this is normal stress. Normal stress acting, this is your surface A, this is stress, this is perpendicular, 90 degrees. Okay, so for the tension and for the compression, it is the same. It must be perpendicular. So the first equation is sigma equals to P over A, or F over A. It's the same. Okay, And the next one is shear. So for this chapter, the keyword is you need to understand the area. Okay, so you need to know area for normal stress. This is the tricky, or area for shear stress. Okay, you look at for the shear stress. So shear stress, if you look at the figure for shear, this is for shear, the force is acting parallel to the area, surface area. So for the shear stress, when we give the load F to the components, to the parts, the area of shear stress is this one. So in 2D, if we look at from here, in 2D, this is F, and this is our shear stress. So it is parallel. So this is the area. Okay, so this is the area. So let's calculate some questions. What is the normal stress if the bar P is 10 kilonewton and the area is 500 millimeter per second? Okay, calculate. If we have the equation of normal stress is sigma is equals to P over A. You have your P, you have your A. Okay, kira berapa P over A? Ada jawapan tak kat situ? P is 10 kilonewton, A is 500 millimeter square. C. Okay. Sini, 10. Ini kena tambah. Apa saya contoh kat tepi je. C. Okay, semua jawab C. C adalah 20 kilopascal. Macam mana datang pascal? Okay. Apa unit pascal? Unit pascal ialah okay. Okay. Newton, yes, Newton per meter square. Unit Pascal adalah Newton per meter square. So you have your sigma is equals to P over A. P is 10 kilonewton. A is 500 millimeter square. So millimeter square to meter. Millimeter square to meter square. Nak kena buat apa? So mm kali mm. Okay, millimeter kali millimeter baru dapat millimeter square. Kan? So millimeter is 10 to the power of 3m times 10 to the power of negative 3m. So kita akan dapat 10 to the power of negative 6 meter square. Okay, so yang ini 10 to the power of 6. This one is Newton and this one is meter square. Okay, so sigma P over A, dia punya SI adalah Newton over meter square. So SI unit, Newton per meter square ni sama juga dengan Pascal. Okay, nampak 10 negative 3. So ini kena kali 2 mm, ini basic mathematics je. Okay, so 10,000 bahagi dengan 510 negatif 6. Jawapan dia adalah 20 kali 10 kuasa 6 Pascal. So 20 kali 10 kuasa 6 Pascal sama dengan, ni sama dengan N. 20 megapascal. Okay, so area dia kita tahu. So ini area yang diberikan adalah area ni. Okay, so next question. Ada soalan tak yang ni? Ni sebelum kita belajar ni, ni just bagi tahu. Mana tahu ada yang dah baca. Shear stress. Shear stress dia sama juga macam normal stress. Dia punya rumus. Tapi untuk shear stress kita pakai tau. Tau is equals to F over A. Or P over A. Sama juga. So dia adalah F yang bertindak lah. Okay. Right. So dalam soalan ni, what is the average shear stress in the internal vertical surface AB? Okay. If F is equals to 20 kilonewton and AAB equals to ACD. So ini area. Okay, ini area adalah AAB ni. Sama dengan ACD. So kalau kita potong, inilah area dia dan sebelah belakang ni area dia. Sebelah belakang So permukaan tu adalah dia punya area. So area dia adalah 1000 kilonewton. Tapi dalam soalan ni dalam soalan ni dia adalah double shear. So dia ada dua permukaan. Jadi dia kena ambil dua bahagian. Tapi tak apalah. Kita kena guna F equals to 2V. Okay. V ni sebab dia punya arahnya. Okay. Ni 1, 2. So untuk equilibrium dia kena samalah. F sama F tolak V sama dengan kosong. Okay, so F equals to 2V. V equals to half over F, which is V is equals to 20 kilonewton divided by 2. Okay, so ni terasing lah, right? Tapi yang paling penting yang awak kena, ini kita akan belajar kejap lagi, dan yang paling penting awak kena tahu adalah sigma untuk normal stress, which is this is perpendicular, and tau is equals to F over A. Saya tak nak teruskan sebabnya nanti confuse F dan juga V. Tapi F ni sebenarnya adalah F yang kita dah kira, calculated. Gunakan statik. Ilmu statik nanti kita akan tunjuk. Ataupun dalam kebanyakan contoh, bagi mengelakkan kekeliruan, dia akan letak V. V over A. Okay? Dan dia ada single shear stress dan dia ada double. Okay, ini kita akan tengok. So apa yang saya nak tekankan di sini ialah you need to know that normal stress is perpendicular and shear stress, dia punya stress parallel. Apa yang perpendicular? Apa yang parallel? Perpendicular and parallel adalah force dan juga area. Okay. So force dengan area tu 90 degrees untuk normal stress atau kita panggil axial load, dan shear stress dia adalah parallel. Okay. So kalau macam ni kita tengok daripada sisi F2D F, okay, so ni dia punya V. So ini adalah permukaan yang parallel dengan force, parallel dengan force dia. Okay. Dia bukan 90 degrees. Okay. Normal stress and shear stress. Okay. The application is the soalannya, where does the average normal stress occur? So normal stress tu occur dekat mana? Dekat surface, dekat all of the components, all of the parts, fine. Okay, so dekat mana? So kita assume lah, okay, dia berlaku dekat surface. Normal stress. Normal stress is the intensity of force acting normal to, okay, so normal to area. In the figure, it shows that we have force, okay, we have force and we have the area. So this is the area, okay. So force and area. So dapatlah kita punya sigma ataupun normal stress. Okay. Examples. Kita tengok examples number 1. The bar has a constant width of 35 mm and thickness of mm. So ini constant width bar ni lah. Bar ni apa? Bar ABCD. The whole bar. The whole bar has a constant width of 35 mm and a thickness of 10 mm. So ini apa dia? So ini adalah dia punya A. A is equal to 35 mm times 10 mm. Beware of mm. Okay. So 35 mm times 10 mm. This is the area. So area in mm square. Kalau nak selamat, you can change it to meter in the first 0.035 meter. Okay, so 0.01 meter. So you got your area in meter square. Kalau yang tak biasa. Determine the maximum average normal stress. Normal stress ni. In the bar when it is subjected to the loading shown. So loading shown, bar yang ini adalah structure analysis lah untuk truss. Okay, kita dah belajar structure analysis untuk truss. Macam mana kita nak dapat dalam equilibrium. So kita potong untuk kita tahu force kat sini. Okay, and then kita potong kat sini untuk kita tahu X kat sini. So bila kita, okay, kejap. So, kita potong sini, kita akan dapat P kat sini lah. Berapa? Bila kita kemudian kita potong dekat sini untuk kita dapat P dekat B berapa. Okay. Lepas tu kita potong dekat sini untuk kita tahu sama ada kita potong dan kita ambil ini sebagai free body diagram ataupun kita potong sini dan kita ambil sini sebagai free body diagram. Dia sama je. Sebab kita dah belajar bila kita potong, dia akan berlawan. Okay. Next, kita tengok example. Okay. So, untuk potong yang pertama, untuk potongan yang kedua, so dalam ni dia, yang kat sini dia dah bagi dia punya width ada 35 mm, so dia punya thickness. So kalau kita tengok macam ni lah. 35, ini 10. So ni dia punya area. Okay, 35 mm. Then finally kita potong kat sini. Okay, so bila first kita potong dekat bahagian AB, so we got PAB is equal F X equals to 0. So PAB minus 12 equals to 0. PAB equals to 12. Okay. Sigma Fx equals to 0. Then we have PBC minus 9 minus 9 minus 12 equals to 0. So PBC is equals to 30 kilonewton. Okay. Finally, we have PCD. Okay, kita potong PCD. Sigma Fx equals to 0. 22 kilonewton. Sorry. Just 22 je. 22 minus PCD equals to 0. PCD is equals to 22 kilonewton. Okay. So ini dalam static kita dah belajar. So kita tengok each and every single part dekat mana perubahan daya berlaku. Okay, ini perubahan. Okay, so kat sini. Okay, so 12, 30, 12, yang ni PAB, PBC 30, PCD 22. Okay, so itu adalah kita nak cari force. Then you choose the maximum value here because of what? In the bar, the maximum value is 30 kilonewton in the bar. The intensity in the bar is 30 kilonewton. So that is the maximum. So you need to know what happened. So kalau 30 kilonewton tu okay, part tu tak fail, then the others should be okay. So we need to know where is the maximum value of stress. Okay, so 30 kilonewton, and then kita calculate lah. Calculate sigma is equals to P over A. Okay, so PBC A 30 kilonewton, itu dalam soalan sorry, ni dalam ni. Okay, 30 kilonewton bahagi A. A is 35 mm times 10 mm. So we got the normal stress is 85.7. Question. Why they didn't take the 4 kilonewton? Oh, okay. Okay. Just to be clear lah. Bagi nampak. Okay. In this part, I've shown this one. Okay. This is in the figure. Okay. So sekarang ni, the question is kenapa tak ambil kira 4 kilonewton? Sebabnya 4 kilonewton, we cut it here. Cut it here. Then we look at this side. Okay. Okay. Kita buat the other side. Okay. Kita buat the other side. Contoh kita potong dekat sini juga sama. Kita potong. Okay. And then we look at this one. So apa yang ada sampai sini So tak apa. Okay, so kita cut kat sini. So dalam free body diagram, apa yang kita ada yang ni. Okay, ini 12, ini kita ada 18, dan ini kita ada 8. 4 plus 4, 8 kilonewton, okay? Alright, and then we want to know what happened to here, PCD. Kan? Betul kan? Okay, so bila kita potong, kita ambil yang sebelah sini lah. And then, sigma fx is equals to 0. Now we have to the right positive. So we have PCD minus 12 kilonewton minus 18 kilonewton minus 8 kilonewton equals to 0. Sorry. Minus, this one pass. Okay, area ni. Direction. Betul kan kalau saya salah? So, PCD is equals to 12 plus 18 minus 8. So equals to 22. So it is the same, just you want to do it this way or you want to do it this way. It must be the same answer. Okay, so kalau kita cantum benda ni, yang ni dekat hujung sini, dia akan jadi macam ni. Nah, ini yang apa yang you study sebelum ni. Cut trusses and then opposite. Okay, so the same. Dulu masa saya belajar pun saya akan ambil this type sebab saya tak confident. Tapi ni saya tunjuk it is the same. So you can use the easiest way lah. Senang. Okay, so in equilibrium. So the maximum value is 30 kilonewton, then kita dah dapat 85.7 megapascal. Okay, example 2. Ni pun dah buat juga kan? Ni pun dalam soalan midterm kan? Okay. So dalam solid mechanics ni adalah additional knowledge yang you kena tahu, tambah. Saya cek kedatangan dia. Abdal ada. Right. Okay. The 80 kilogram lamp. 80 kilogram lamp is supported by two rods, AB and BC. So this is the weight, mass. So W is equals to mg. G is gravity. M is 80 kilogram. 80 times 9.81. So we got the answer in Newton. Okay, mesti dalam Newton. It's supported by two rods AB and BC. So kita ada rod AB and BC. If AB has a diameter of DAB equals to 10 mm, DBC is equals to 8 mm. Determine the average normal stress in each rock. Macam mana nak tahu normal stress? Normal stress is equals to sigma is equals to P over A. A, you have your A given. The diameter is 10 mm, so A is equals to pi D over 2 square, or pi D square over 4, or pi J square. Okay, so you know your A. And then you need to know your P. So you need to calculate your equilibrium of forces for A, AB, and BC. So from this one, you have W 80 kali 9.81, and then you have your TAB, TBC. Okay, right. So okay, FAB and FBC. So you need to solve the static first. Okay, you need to solve your static first. So this is your static, FBC, FBA, and this is weight. Sigma Fx equals to 0, sigma Fy equals to 0. So you can divide your FBC times 4 over 5, FBC times 3 over 5, and then again FAB sine 60, FAB cosine 60, and W. So Fx and Fy, solve your Fx and Fy, and you got your FBC, FBA, sigma is equals to P over A. So this is your P. Okay, so you need your static to solve your solid mechanics. Right, so after that you can calculate your normal stress. Okay, so normal stress for diameter of BC is 8 mm, and diameter for AB is 10 mm. So calculate your A, and you get from the equation of equilibrium, you get your FAB and FBC. So this is your stress, normal stress. Okay. Number 3, member AC is subjected to a vertical force of 3 kilonewton. Nah, ini soalan lain pula. Determine the position X of this force so that the average compressive stress at the smooth support C is equal to the average tensile stress. So it is equal. Equal ni equation lah. Equation apa equals to apa. Okay. Kita tengok. In the tie rod AB. So ini rod AB. The rod has a cross-sectional area of 400 millimeter square. And the contact area at C is 650. So dalam soalan, average compressive stress at the smooth support C. So dekat sini, equal the average tensile stress in tie rod AB. So ini yang sini sama. Sama dari segi apa? Average tensile stress, sigma average P over P. Okay, so kita tengok free body diagram. So free body diagram, kita ada Fx, dan yang ini adalah kita ada Fx, kita ada Fy, kita ada moment. Kan? Okay, so for now, X tak ada. So semua dalam Y. So ini AB is in Y direction, 3 kilonewton in Y direction, FC in Y direction. Okay, so we need to solve our equation. So buat dua equation, yang ini tak ada. So we have FAB plus FC. Okay, FAB 1, FC 1. Sorry, 2. Unknown. FAB is unknown, FC is unknown, negative 3000 Newton, 3 kilonewton, okay? And moment at A, so moment taken at A, and we don't even know this one. So this is 3 unknown. So you have 3 unknowns with 2 equations. You cannot solve. Okay, so you need another equation. So the third equation is from the question where sigma at C is equals to sigma at A. Tensile on the rod and at the surface C. So FAB divided by the area of AB, this one. And FC divided by the area of C, given from the equation. So this one, we can have the third equation. Okay. So the third equation can be put in equation number 1, and you can solve your FAB and FC. Okay. So from equation number 2, you have your FC, and you can get your X. So this is the X from here. Okay. So X is equals to 124 millimeter. Any question? So 3 examples. Okay. Okay. Any questions? Tak ada. Okay. Kalau tak ada, saya sambung untuk shear stress. Okay. So shear stress, intensity of force acting tangent, collinear, parallel. Collinear, parallel. Macam saya sebut tadi, F, V, V. So the area is this one. The force is this one. So it is collinear or parallel. Dia tak perpendicular macam normal stress. So that is the difference between normal stress and shear stress. So from the figure, it shows that at single shear, this is single and this is double shear. So we look at the first one, single shear, figure A, this is the one, okay, and CD is another one, the same as double shear. So we look at the single shear. So when we take out the, we remove the upper side, okay, so when we have a bolt and nut, the shear stress is happening on bolt and nut. Okay, so that is the force. Okay, the force is acting that side and that side. So the surface area for pin and bolt for shear stress is this one. Okay, if we look in 2D, okay, that is the force, and this is the surface. This is the area. So it is parallel. Next, we look at when we have a plate attached with each other, fully attached, sama ada gunakan gum, glue, or whatsoever. If we have F and it is in shear, so this is the area, the whole area that acting for the shear stress. Okay, if we look in 2D, okay, so the area acting for shear stress is this one, the parallel. Okay, so tu kena pastikan dan fahamkan antara normal dan shear. Okay, next, double shear. Double shear ni dia tambahan dia. Maksudnya kalau ini 2 plate, yang ini 3 plate, so kita ada 2 force. Okay, 2 force ke kiri dan 1 force ke kanan. So dalam force yang terlibat, kita bahagi 2 lah. Okay, F bagi 2. Untuk kekalkan dia equilibrium. Okay, so dia samalah. So dia ada 2 daya dan 1 daya. So setiap 1 daya yang sebelah sini akan ambil half lah daripada yang sebelah sini. Okay, so sama juga untuk double shear. So dia punya area bertindak adalah yang atas dan juga yang bawah. Okay. Example. The wooden strap is suspended from a 10 millimeter diameter steel rod. So, wooden strap. So, yang mana yang wooden? Yang ini ke yang ini? Okay. So, kalau tengok tu pun tahu yang mana yang strap, wooden strap dan juga steel rod. Okay. So, rod yang AD itulah ni steel rod. Okay. Which is fastened to the wall if the strut supports a vertical load of 5 kilonewton. So this is what we call vertical load. Compute the average shear stress V over A ataupun F over A in the road. So soalan dia in the road at the wall and along the two shaded planes of the strut. So kat sini juga. Okay. One of which is indicated as A, B, C, D. Alright. So kita ada shear stress, kena ingat V over A ataupun F over A, and then kita kena calculate lah kita punya A. Ni 10 mm diameter, so kena cari A dia berapa. Ini 20 kali 40, so kena cari A dia berapa. Okay, so kita ada dua jawapan So for the road, so kita tengok dekat road dulu. As shown on the free body diagram in figure B, the road resists a shear force of 5 kN. So ni single shear where it is fastened to the wall. A free body diagram of the section segment of the strut that is in contact with the road is shown in figure C. Here the shear force acting along each shaded plane is 2.5 kN. So untuk plane ni adalah double shear. Okay. Jadi untuk road, okay, so untuk road dan untuk strut, okay, wooden strut. So untuk road kita guna V sama dengan 5 kN lah. A kita kira A is equals to pi J dia adalah 10 mm bahagi 2, 0.005 meter square. Nah ni, okay, ada. So kita dapat calculate our shear stress dan untuk strut V adalah 2.5 kN. Okay, 2.5 kN sebab equilibrium. Okay, double shear, right? Equilibrium, so F sama dengan 2V. V is equal to F over 2. Okay, so 2500 Newton. Dia punya A adalah ni tadi A is equals to 20 mm times 40 mm. Atau you boleh terus tukar meter times 0.04 meter. Okay, so dapat you punya shear stress. Okay, so dalam tu you have to imagine the section area for each part due to shear stress applied. So kena imagine. Okay, so kena guna imagination untuk imagine yang parallel tu. Okay. Okay. next example. So ni kita pasal shear stress shear stress. So normal stress tadi dah 3 example, and this is example 5 for example number 2 for shear stress. Determine the average shear stress in the 20 mm diameter pin. So ini untuk apa? What is this for? A. Pin at A. So ini adalah pin. So diameter is 20 mm. And the 30 mm diameter pin at B. So ni pin. Diameter at B. From the figure. Okay. So from here and from here, you can already know the trick question. Okay. The tricky is about the single shear or double shear. So from the figure, we can we know that it is double shear, and from this one it is single shear stress. Okay. Free body diagram. Free body diagram untuk apa? This one. So kita ada that one, pin, okay, and this is actually acting at C. So that is the free body diagram to get what is AX, AY, and FBC. Okay. So bila dapat F, barulah kita boleh kira the intensity dekat rod dan pin. Okay. So bila kita tahu intensity force, baru boleh kita boleh kira intensity at pin. Apa yang berlaku. Okay. Free body diagram. So kita ada AX and AY. So ini free body diagram. Then static equation of equilibrium. So we can calculate our FB, our AX, and our AY. Okay, so AY dekat A is double shear, B is single shear. Okay, so first one we calculate at pin A, so we get a resultant force of 20.36 kN because of the AX and AY direction. Okay, so this is A. Okay, so at point A it is double shear, so F is equals to 2V. V is equals to half of the F. Okay, so calculate the V, and then at pin B you can calculate your single shear. So this is for A, this is for B, and then you calculate your tau is equals to V over A. Then you can get your shear stress of A and B. Okay, average shear stress. This average shear stress. Okay, so kenapa nak kena study the intensity, normal stress dan juga shear stress? Kenapa nak kena study normal stress dan juga shear stress? Kita kena study, we need to study about normal stress and shear stress to determine it is either our design, like this one, we design component that have a load like that using magnesium. Okay, so our material of pin, let's say our material of pin is magnesium. So kat sini, let's say ni pin ni, okay. What happen if we use magnesium? What happen if we use aluminium? What is the best material to be the pin? Okay, so that is why we need to know the normal stress and also the shear stress. Okay, next we want to look at the safety factor. Okay, so from the examples, okay, from the examples, okay, this is example 1. You have calculate your normal stress and you get your normal stress is 85.7 megapascal. Okay, and then you calculate your normal stress in this example, and then you get your normal stress of root AB and BC. So it is in megapascal. Okay. Next, you calculate FAB. Actually, you can calculate the sigma here. Okay, you get your FAB. FAB is 1143. Sigma is sigma AB. Let's calculate. Sigma AB is equals to 1143 Newton divided by 400 400 times 10 to the power of negative 6. Okay. Two point 8586 megapascal. Okay, so you calculate your normal stress of root AB. Okay, so megapascal. You calculate your shear stress, and then you got your answers 63.7, 3.12. That is the shear stress. So you have calculated also this one. You got your shear stress for 34 megapascal and 17.7 megapascal. So this one, the unit is normally in megapascal or pascal. Mega is 10 to the power of 6. Okay, so this is what you have. This is what you calculate from the load given to your components. Okay. Now, kita nak tengok, we want to look at if the load given is acceptable, is okay for our components, and is it reliable, and also can our part fail because of the load given. Okay, so now we are looking at the okay. Now we are looking at the stress strain part 2, which is wrong calculation results to accident. Somehow in the figure, we have you have studied, you have learned about normal stress. You have learned about shear stress. And before you get your normal stress, you have your equation of equilibrium, sigma fx, fy, moment equals to 0. So you want your unit, your design to be static, okay, to be not moving, okay. So this one you have studied, but we have a lot of load given, like a vibration, fatigue, dynamic. So you will learn a lot lah. Okay, now we discuss about the safety factor or factor of safety. Like before this, from the question, you calculate and you get your answer for stress is 85 megapascal. Say like that. Okay, 85 megapascal. So, contoh, example, the maximum stress allowed to be applied on a structure. Okay, if we put and give load 8, can our our model, our design sustain, or is it can it fail? So, what is the a reference for us to know to design our our components, our products, okay, our bridge, our building, our car engines. Okay, so is it can it fail? So we don't want it to fail our product designs. Okay, so the stress allowed to be applied on a structure. Factor of safety is a ratio of failure stress to the allowable stress. Failure stress to the allowable stress. So what is the allowable stress of our design? As an engineer, you have to determine the allowable stress value based on the factor of safety. Normal force requirement. So this is, we have sigma is equals to P over A. A is equals to P over sigma allowable. Okay, so we calculate for shear, tau is equals to V over A, and we have A is equals to V over tau allowable. Okay, given the applied load given to your product components, part, and allowable stress value, engineer can determine the required surface area to support the load using the formula stated. How can you determine the allowable stress value? Okay. This is the some examples like the previous one, but with the load 6 kilonewton, 2 meter distance. So we need to calculate the diameter pin A and B. Pin inside here. This is pin. Okay, and this is pin. Diameter pin A and B, diameter rod BC. So this one also. Okay, so from the free body diagram, from the calculation, now we have calculate our AX, AY, and we have calculate our FBC. Okay, so this force will be using for the shear V over A. Okay, so A is equals to diameter is pi j square or pi r square. Okay, or pi r square, so that we can get our diameter net. Okay, so we look at pin at A. Okay, pin at A, here A is double shear and pin at B is single shear. Okay, so that you calculate when you have double, you have F minus 2V equals to 0, F equals to 2V, V equals to F divided by 2. Must be divided by 2. Okay. Then single, use the same value. Then when you calculate, you can find your diameter. Okay, this is the diameter. So you should choose the bigger diameter, 7 mm and 10 mm, larger than the calculated value. So my question, how you define your allowable shear stress? Okay, so the allowable shear stress, some static ada. Okay, belum ada. This is depends on the material. So we have a table of the stress for our material. Okay, so we have aluminium, we have steel, we have magnesium. So all of this material are different in allowable stress. They are what we call is mechanical properties. So when you design, you need to know all of this. It is referring to the table, but like in the question, it should state that the allowable shear stress is equals to 90 megapascal. Okay, then you have to calculate. Given is allowable stress, allowable shear stress. Okay, right. So ABC. Okay, so given ABC is 105 megapascal. This is tensile for root BC. Okay, right. So it is depends on the material, the allowable stress and allowable shear stress. It depends on the materials, and normally it is given in the question. Kalau ada soalan, dia akan bagi maximum stress allowed. Maximum shear stress allowed is, so you are using that value. Okay, so that is the allowable stress. Now, we try to look at this strain. Stress, number one, why? So we always pronounce it as Y to X diagram. Okay, Y to X diagram in this figure is stress strain diagram. Okay. This is the common stress strain diagram for ductile materials. ductile materials, mulu. So kita ada two types of materials. One is ductile, the other one is brittle. Okay, so this one is for ductile materials. So for ductile materials, we call it a stress strain diagram, or ada lecturer lama saya call it as graph gajah, maybe, mungkin sebab nampak macam gajah whatsoever, tapi just call it stress strain diagram. And this stress strain diagram is calculated, is drawn using a tensile test. We call it this one, tensile test. Okay, tensile test. So nanti kita akan tengok details. So untuk safety factor, okay, tadi kita dah belajar contoh yang kita load yang dikenakan adalah 85 megapascal. Okay. Materials tu boleh allow stress sampai 170 megapascal. Let's say allowable stress. So the safety factor is equals to allowable divided by load given. Okay. Tu lah. The safety factor is 2. And then this is the some kind of loading, okay, and the suggested safety factor that we can take. Okay, so if our safety factor is below than 1, it is considered fail. Okay, considered fail. So safety factor is ultimate stress divided by actual stress. So given load. Ultimate stress divided by allowable stress. So this also given load. Okay, given or calculate. So that is the safety factor. Examples: factor of safety, load that breaks the product. So 4,000 Newton, the product will break. You give only 1,000 Newton. So the factor of safety is 4. 4,000 divided by 1,000 is equals to 4. Okay, so that's it for today, and we will continue our class in next week, which is, and we will discuss about the chapter 8 also. Okay, and then on Wednesday we will discuss about a tutorial. I will upload also the tutorial. Okay, any questions? Jangan tanya pasal midterm. Belum sempat tengok jawapan lagi. Ada soalan? Okay, kalau tak ada, kelas kita sampai sini sahaja. So I will see you in next Tuesday 10 AM. Kalau ada apa-apa boleh tanya saya dalam grup. Okay, alright, itu saja. Thank you very much guys. Assalamualaikum warahmatullahi wabarakatuh, and class dismissed. Thank you. You're welcome. yang cepat-cepat left, cepat left group.